Good day. This is fundamentals of big data. So let us try to understand what is big data all about. Then we will proceed with the characteristics of big data and try and understand what are all the areas where this big data is being utilized. Then we will proceed towards the benefits of big data, then risks behind this big data, and also about how exactly the data gets generated out of this big data, and how it's getting processed, and how we can try to analyze it. And also, we'll try to have an architecture of this big data. What are the different layers behind this big data? And let us proceed with all of this moving forward. So let us begin with the big data. So big data may well be the next big thing IT world. Big data burst upon the scene in the first decade of the 21st century. The first organizations to embrace it were online and start farms. Firms like Google, eBay, LinkedIn, and Facebook were built on big data from the beginning. Like many new information technologies, big data can bring about dramatic cost reductions, substantial improvements in the time required to perform a computing task or new product and service offerings. Big data is similar to small data, but bigger in size, having data where different approaches, techniques, tools, and architectures are being utilized. And aim to solve the new problems or old problems in a better way is what we do with this big data. Big data refers to data sets whose size is beyond the ability of typical database software tools to capture, store, manage, and analyze. So repeating it again, big data refers to data sets whose size is beyond the ability of typical database software tools to capture, store, manage, and analyze. Big data generates value from the storage and processing of very large quantities of digital information that cannot be analyzed with traditional computing techniques. With that, we have an understanding about what is this big data all about in the usual process behind it. So, with that said about the basic definition of big data, let us move on to the characteristics of big data. So, when we say characteristics, you can remember it as three V's. There is volume, velocity, and relativity. So, beginning with volume, it's about the quantity of the data, and velocity is about the speed with respect to the data, and variety is about the type of data that we gather or the influence services. So let us try to understand these characteristics one by one, beginning with the volume. A typical PC might have had 10 gigabytes of storage back in the year 2000. But today, Facebook ingests more than 500 terabytes of new data every day. So that's humongous. So let's talk about Boeing 737. That type of airplanes, they generate 240 terabytes of flight data during a single flight across the United States. So again, something huge amount of data. The smartphones, the data they create and consume sensors embedded into the day-to-day objects will soon result in billions of new, constantly updated data feeds that is from the environmental location and other information. We are also talking about huge number of videos that also needs to be stored in. That is about the volume. So let us understand about the velocity. So click streams and ad impressions capture user behavior at millions of events per second. So high frequency stock trading algorithms reflect market changes within microseconds. So machine to machine processes exchange data between billions of devices. Infrastructure and sensors generate massive log data real time. Also, online gaming systems support millions of concurrent users, each producing multiple inputs per second. So you can see the way in which the data is getting gathered with respect to the velocity or the characteristics of the data. So the variety is another characteristic. So big data isn't just numbers, dates, and strings. Big data is also geospatial data, 3D data, audio and video, and structured text, including log files and social media information. Traditional databases were designed to address small volume or variety of data. Fewer updates, uh, predictable, consistent data structure. Big data we are referring here involves different types of data. So, with that said about the characteristics of big data, let us see in what way are we working with such big data. So, to begin with, the various generation points of this data are listed out, beginning with the mobile devices, microphone readers, scanners, science facility programs, software, and social media factors. So through this, you are able to generate plenty of data. So with that generated, you cannot leave it. So you need to store it somewhere so that you can further proceed with other process within you. So for storage, you need to analyze your data characteristics because how exactly are you trying to put them in so that you can replace it or further processing it. So selecting the data source for analysis is extremely vital. Eliminating the redundant data. So I do not want to have something that's already existing. So duplication has to be avoided. So establishing the role of NoSQL. So all these things are behind this storage of big data. So overview of this big data stores, so data models, key value, graph, document, column found, and then HDFS that is a distributed file system, HBase and I. So all these are the big data stores, possibility of the way in which we preserve. So selecting the big data. With that said, you wanted to choose the correct data stores based on your data characteristics. So moving forward to data, implementing polyglot data store solutions, aligning the business goals to the corporate data store. So what type of business, what exactly are you trying to achieve out of this data that's being gathered? So you need to select the specific ones that you want. With that done, that is about generation, storing, selecting you want to process. So integrating the disparate data stores, mapping the data to the programming framework, connecting and extracting the data from the storage, transforming the data for processing, subdividing data in preparation for Hadoop MapReduce. So this Hadoop MapReduce are the components of the ecosystem. We try to understand that this is about how exactly you employ this Hadoop MapReduce, that is creating the components of how exactly you want this task to be carried out. That is the jobs. Distributing the data processing across server farms, executing Hadoop MapReduce jobs, monitoring the progress of those jobs getting thrown. So with that said, we'll see how exactly is this big data being different. So it's automatically generated by a machine. So I have a sensor swing embedded in the engine. Typically, an entirely new source of data. This example, use of the internet, not designed to be friendly. Example, text streams. So they will not have much values. So big data is going to be different in these cases. So why is big data? Why am I trying to utilize this? The growth of big data is needed because we are talking about plenty of storage. It's involved because of the data that's getting gathered. So increasing of processing power, availability of data. So I'm talking about different types of data. So every day we create 2.5 quintillion bytes of data. So 90% of the data in the world today has been created in the last 2 years alone. So we see about the amount of data that's being generated just in this one decade. So Facebook generates almost 10 TB of data daily. Twitter generates 7 TB of data daily. So both these organizations together will see the amount of data they generate. So IBM claims that 90% of today's stored data was generated in just in this decade. So that's something really huge. Most of the content has been generated recently. So with that said, let us see what is the structure of this big data. That is, how exactly is this big data being generated and how do you identify the harm? So to begin with, unstructured data. This is the data which does not conform to a data model or is not in a form which can be used easily by a computer. So about 80 to 90% of data of an organization is in the format, for example, memos, chat rooms, PowerPoint presentations, images, videos, letters, research documents, white papers, and the body of it. So all these things you can put it under unstructured data because they are not in compliance with a specific data model. Or I can also say that it's not something that's easily processed in the program by a computer. That said, let us see what is this semi-structured data. So this is the data which does not conform to a data model, but it still has some structure. So however, it is in the form which can be used easily by a computer program. For example, like emails, extended market reviews, XML, and HTML, hypertext markup. So metadata for this data is available, but it's not enough or not sufficient. So then the other type, so we have seen about structure, semi-structure. about structured data. So this is the data which is in organized form. So I can say it has proper rows and columns and can be easily used by people because it's well organized, having the necessary information. So it can be processed easily by a computer. So relationships exist between entities of data, such as classes and their relationships stored in database. I can say that is a structured data. So with that said about these three types, that is unstructured, semi-structured, and structured data. And we have also seen some examples of these three structured respective data. With that said, this is the big data analytics and its architecture. So when I say big data analytics, what are we referring to? We are talking about examining huge amount of. So we try to identify what is the information available in that. If there is any specific patterns that's hidden there. We try to understand if there is any relations, specific relativity between the different information that's provided. So competitive advantage is the with the data that you get, and you're able to take better business decisions, strategy, operational types. With that type of strategy you try to use, you're able to do better marketing for your organization, and that will obviously lead towards customer satisfaction and end up in increased revenue because end of day organizations want to spend less amount of money and try to make the maximum of the investment you're making. So with that, how exactly this big data analytics is done? So this is the architecture. You can see the different layers that's there. So to begin with, it's the infrastructure layer. Then there is data networking layer. There is data security layer, which we have authentication, authorization, and the next layer after data security is the storage layer, where we are referring to database like MongoDB. And just above that, we have this data processing layer, which is what tools like Apache Spark. And next layer is the data query layer. So here is the analytics engine. And finally, the data visualization layer, where you try to project the content that has been generated. So you want to portray what is that you have identified the patterns. So one of the tools is this Tableau, which helps out the organization represent the processing that they have done in the data they've gathered. So with that, they will be able to take appropriate decisions and identify certain things. So this particular visualization that's generated through these tools from the data that's been gathered really helps the organizations out. So with that said about the architecture, we will move on to the applications of big data. When we say applications of big data, it's about where exactly are the different industries that make the maximum out of this analytics done with the big data. So to begin with, let us talk about healthcare industry. So big data and healthcare are an ideal match. It complements the healthcare industry better than anything ever. So the amount of data the healthcare industry has to deal with is unimaginable. Gone are the days where healthcare practitioners were incapable of harnessing this data, from finding a cure to cancer to detecting Ebola and vaccine. Big data has got it all under its belt, and researchers have seen life-saving outcomes there. So you can see that healthcare industry really utilizes this big data, the way to identify what is the patient uh, suffering from since when, or about the diagnosis that's been done. History. Can we try and find the pattern of it? Say the people suffering with that, what other things we need to take into consideration? Next is about the education. So when you ask people about the use of the data education institute gathers, the majority of the people will have the same answer. The institute or the student might need it for future references. Some of the universities are using big data as a tool to renovate and provide better curriculum. So additionally, universities can even track the dropout rates of the students, and they can take the required measures to lower down this rate as much as possible. So you can try and find out what exactly the students are feeling, the number of students you can try to get understand, not to see what the universities can plan and proceed towards lowering that dropout ratios by improving research masters. With that said, let's move on to the other application, which is finance. The functioning of any financial organization depends heavily on its data. And to safeguard that data is one of the toughest challenges any financial firm faces. The data has been the second most important commodity for them after the. So that's how the fintech really works. So digital banking and payments are two of the most trending buzzwords around, and big data has been at the heart. So big data is causing the key areas of financial firms such as fraud detection, risk analysis, algorithmic trading, and customer content. So this has brought much needed fluency in their systems. They are now empowered to focus more on providing better services to their customers rather than focusing on security issues. So big data has now enhanced the financial system with answer towards hardest of the challenges. So you can see how exactly big data is complementing the financial industry and how exactly they can help our customer to have that trust and proceed further with them. Next is telecom. The telecom industry is the soul of every digital revolution that takes place around the world. So with the ever increasing population, smartphones just flooded with telecom with massive amounts of data. Companies now, with the help of big data analytics, can track the area where needs improvement as well as the highest network impacts, traffic sampling, doing the needful to ensure we provide better connectivity. Big data, like other industries, have helped the telecom industry to undergo changes and do that pretty well. Next is the retail. So the retail industry is one of the industries that faces the most fierce competition now. Retailers constantly hunt for ways that will give them competitive edge over others. Customers are the real big king, someone's legend of the retail industry. But through advanced analysis of their customers' data, retailers are now able to understand them from every angle possible. They gather this data from various sources such as social media, loyalty programs, etc. Even a minute detail about any customer has now become significant for them. They are now closer to their customers than they have ever been. This empowers them to provide customers with more personalized services and predict the demands in advance. So that's what any industry wants. We want to understand what are the requirements of the customer, how exactly we try and build so that we're able to provide as an industry. Next is e-commerce. It's one of the greatest revolutions this generation has seen is that is of e-commerce. It is now part and parcel of Indian life. Whenever we need to buy something, first thought of the promotes our mind is e-commerce. It's not just the price. Big data is being based on it. Big data's recommendation engine is one of the most amazing applications the big data world has ever seen. Furnishes the companies with a 360-degree view of their customers. Companies then suggest customers accordingly. Customers now experience more personalized service that they have ever had. Big data has completely redefined people's online shopping experiences. Next, another industry is automobile. So, a business like an automobile has to be driven in markets. This was said by famous author recent folks. And big data has now taken complete control of the automobile industry and is driving it smoothly. Big data is driving the automobile industry towards some unbelievable and never before results. The automobile industry is on a roll, and big data is its wheels, or I must say, big data has given wings to it. Big data has helped to help the automation or automobile industry achieve things that were beyond our imaginations. So the contribution with respect to the big data is very good. So with all those applications listed out, let us see what are all the risks of big data. So it will be so overwhelming. Need the right people and solve the right problems. Next is cost escalate too fast. So many sources of big data is privacy. So as you can see, with so much amount of data under the responsibility was the amount of care that needs to be taken in order to make sure that the data is in the safe hands and also needs to be taken forward in the right direction. So with that said about the characteristics, the risks of big data, let us see about the benefits of big data. So begin with real-time big data isn't just a process for storing petabytes or exabytes of data, but it's the ability to make better decisions and take meaningful actions at the right time. So how exactly are you utilizing the content in order to take proper decisions. That's the key. Fast forward to the present and technologies like Hadoop give you the scale and flexibility to store data before you know how you're going to process it. So technologies such as MapReduce, Hive, and Impala enable you to run queries without changing the data structures beneath. So the newest research finds that organizations are using big data to target outcomes, tap into the internal data and build a better information ecosystem. Big data is already an important part of the 64 billion database and data analytics market. It does offer commercial opportunities of a comparable scale to everyone to enterprise software in the late 1980s. And the internet boom of 1980s and the social media explosion so much of data. So with that said about we clearly understand how much benefits do we have in this big data and where exactly that being used with this different applications and we did see about the characteristics of big data that was already last few variety. Now let us see some MCQs which if you have listened carefully from the first, you will be able to identify what will be the option for these two questions. So what we'll do is we'll try to have at least 3 minutes for these two questions. This 90 seconds. And we'll see if we are able to identify the correct answer. So the first question being which of the following is an example of semi-structured data? Then what type of data is organized in rows and can be easily used for computer program? So we'll just give you some time. Let's take approximately 3 minutes from these two questions. 20 almost 2 minutes is finished. Still have 1 minute to go. 15 more seconds. So that's time. So 90 seconds each. So let's get on to the first question. So which of the following is an example of semi-structured data? So this is the structures of big data. So we have seen about unstructured data. Then we saw about semi-structured data and structured data. So they are trying to understand what is semi-structured data and they want you to identify out of the four which one will be the right answer. So the right answer is emails. So it has a part of the structure. It's not completely unstructured or extremely structured like information was there in the search. So emails are semi-structured. So next question is what type of data is organized in rows and columns and that can be easily used by computer. So the options are unstructured data, semi-structured data, structured data, and metadata. So the right answer for this, where we are talking about rows and columns, it's being properly organized and that's being utilized by computer program without any hassles. So that's going to be structured data. So that's the right answer. So for these two questions, shall be taken from the content that you already seen viewed right now. So which of the following is an example of semi-structured data, which is emails? What type of data is organized in rows and columns? It can be easily used for computer programming, which is structured data. So with that said, we've seen about, let us see a little recap. We have seen about what is big data all about and what are the different characteristics of big data. That is the three B's, which is velocity, variety, and then move on to big data semantics, its architecture, and then about the risks behind the big data, and also about the benefits of the big data. That is how exactly contributes, how exactly can be used. Also the applications of big data, which is extremely vital. The different industries trying to process the data that's getting gathered along and what is the hidden pattern behind it. So then we did talk about what are all the different ways in which you get benefited out of this big data that's coming. So with that said, we come to the end of this particular topic. So the reference for this is the textbook, which is titled Big Data and Analytics. This came back in 2020 through the Wiley publications. So the content that you're seeing about the big data and cohesive way of portraying the content is out of the book that's referred to. So for additional information about the volume, quality, city, and about how exactly these industries are utilizing the data, and how easily structured data is utilized for the computer programming, the unstructured and semi-structured data, which is operations. So this textbook should provide you that detailing about the different industries utilizing the data. And with that, we come to the end of this particular topic. So more information can be taken from this particular textbook. And I really thank you for your patience in listening this whole video introduction towards the fundamentals of big data. Thank you.